Hello everyone. We are Integrated Project Group 11, consists of group members Yap Shaning, Hasha Amalia, Nur Arsha Sofia Ismail, Nur Iwani Nazati, Shekina Putin and Lau Zihang and Ahmad Farhan Hanzola. Will be presenting for two courses which are Environmental Chemical Engineering and Process Safety and Loss Prevention.
The equipment assigned to our group is Chris chamber. In EC part, we will discuss about the principal working machine of the Chris chamber, the impact of the Chris chamber operation on the wastewater quality, and also additional information about the Chris chamber. This is the diagram of Chris chamber. Chris chamber is a device that your kitchen wastewater flow through on the way to the savvy. Chris chamber also is any intersector, arrestor, tank, or pit situated above or under the ground that allow cooling and separation of Chris from used water. Now I will explain about the working principle of the Chris chamber. Chris chamber works on the basis that animal fats and vegetable oil, which is a Chris, are 10 to 50% less dense than the water, and the Chris will not mix with the water. Thus, the fat and oils will float on the top of the water. When the wastewater enters the Chris chamber, actually, the time between the cleaning or pumping up the chamber will depend on the amount of the wastewater produced and the size of the clean tract, but it's usually every 2 to 4 weeks only. The solution that combines the non-pathogenic bacteria with nutrients and enzymes to break the fat oil cleanse, which is called as FOG, will edit cleanse chamber performance. This process is commonly referred to dosing. The dosing can be also implemented at the outlet stage as a further method of preventing the FOG building up in the internal piping.
I will continue with the environmental impact from the application of the grease chamber in the wastewater treatment plant. Many wastewater treatment plants are already creating their own sources of energy from sludge left over from the wastewater treatment process. Just as decomposing food waste in landfills produce methane, anaerobic digestion of sludge at treatment plants also creates the greenhouse gas. When captured, methane can be burned and used to produce electricity to run the plant, reduce the dependence of fossil fuel in order to generate energy, as well as cutting the costs which become the target of most wastewater companies. Scientists also have recently discovered that adding specific amount of fat, oil and grease, or we can use the term FOGs, to the sludge in the digester provides a high energy food source for the digester bacteria and can produce more than twice as much methane. This means that the good bacteria can last longer to treat the wastewater and are effective in discharging clean water according to the standard. Any used oil and grease that makes its way into the environment will coat the wildlife, which essentially suffocates plants and animals at the sea or river. If the FOGs are not cleaned up quickly, they can destroy an entire ecosystem. This is the biggest impact that we can see if the grease is not removed before being discharged to the open water. When the grease is removed, we can save wildlife, especially the endangered species, and also secure our drinking water source from the harmful chemicals contained in the FOGs.
Alright, so Lana, now let's move on to the advantages of grease chamber. The first one is to prevent sewer blockage. Grease chamber effectively capture and retain fat oils and grease, preventing it from solidifying in sewer pipes and causing blockage. This blockage usually can cause disruptive sewer backups and repair. So preventing this blockage can avoid unnecessary cost. Next is to improve wastewater treatment. By removing fat oils and grease at the source, grease traps contribute to improve the efficiency in downstream wastewater treatment process. Reducing the contamination in the treatment system can lead to the better treatment outcomes and also can lower the cost for the treatment plants. The other advantages of grease chamber is that we can save costs using grease chamber. Even though grease chamber require the maintenance, the costs associated with regular cleaning are typically lower as compared to expenses you need to repair sewers because of blockage or any because of the build-up by FOG. The other advantages is that the longevity of plumbing infrastructure is maintained. Grease chamber protects the plumbing infrastructure from any FOG-related damage, which can extend the life of sewer pipes and also reducing the need for frequent repairs or replacement. Now let's move on to the disadvantages. We have first is the limited capacity. Depending on the size and design of the grease trap, there is a limited amount of AOG that it can hold. High volume establishment may need larger grease traps or frequent cleaning. Next is the requirements for maintenance. Grease chamber require regular cleaning and maintenance to function effectively. If it is not maintained properly, the trap can lead to reduced efficiency and potential odor issues. The next one is no solid removal. Grease traps are not designed to remove solid food particles from wastewater. It is just to separate the solid removal. Therefore, these solids can still contribute if not managed properly or if not maintained properly. Lastly, inadequate use or installation. The grease chamber, if not properly installed or used, it may not effectively capture FOG, reducing it to release into the sewer system and negating its purpose.
Hi, my name is Ganapatin and I will be explaining about the PNID of the grease chamber. So this is the schematic representation of the piping and instrumentation that gives an overview of the grease chamber. The PNID includes a symbol representing various instruments such as the level indicator and also the pressure gauges, and this gives vital information of the apparatus to control the process effectively. The manhole is also built as an opening that provides the access of the worker to perform inspection, repairs and also maintenance. At the middle of the PNID is the grease chamber, which collects and holds the incoming wastewater. The inlet pipe brings the untreated wastewater, assuming that it is from the grease chamber, into the grease chamber, while the outlet pipe carries partially treated wastewater to the next treatment stage. To ensure the grease chamber functions efficiently, a level sensor keeps track of the grease accumulation, triggering the grease skimmer when it's needed. It does include a vent pipe to release accumulated gas and also responsible to remove the grease that accumulates on the surface of the chamber. The safety is also important, so this grease chamber has pressure relief safety valves to release excess pressure if it is spilled. The pressure sensor is also equipped to monitor operating condition. The arrow indicates the direction of flow, showing how wastewater move from grease chamber through the grease chamber. The inlet pump facilitates the intake of wastewater into the plant, maintaining a consistent overview and preventing the backflow. On the other hand, the outlet pump and also the valve is responsible for moving the treated effluent to the discharge point, accounting for elevation difference and also enabling flow rate control. For the next part, I will be explaining about the potential hazard. The first potential hazard that had been identified is the fire and explosion. The grease chamber can accumulate flammable substance like grease and oil, so which can create an environment conducive to fire and explosion. If an ignition source is present, such as hot surface or electrical equipment, it can lead to hazardous situation. The next is the toxic gas emission. As grease decomposes or reacts with other substance in the chamber, it may release toxic gases. If these gases are not adequately vented or controlled, they may pose health hazard to personnel working nearby. The third is the blockage or overflow. The accumulation of grease chamber and solid material can lead to blockage within the grease chamber. An overflow of wastewater might occur, potentially causing flood or compromising the functionality of the entire wastewater treatment system. The last one is the corrosion and structural. The grease chambers are often constructed of metal and accumulated of grease and other substances that may lead to corrosion over time, and this could compromise the structural integrity of the chamber, leading to leaks, spills, or even collapse.
Hazard and operability study is a systematic and comprehensive approach used to identify potential hazards, deviation, and operability issues in a process or system. During the hazard analysis of our system, the feed pump was evaluated to uncover potential risks associated with higher pressure, low pressure, high flow rate, and no flow situations. High pressure scenarios were examined, and the risk of over-pressurization leading to pipe burst or damage to downstream equipment was identified. To mitigate this risk, it was recommended to install pressure relief valves to prevent excessive pressure buildup and ensure the system operates within safe limits. For low pressure situations, potential issues such as pump wear, faulty pump motors, and reduced pump efficiency were highlighted as causes for concern. To address these problems, the hazard analysis suggested performing regular maintenance, replacing worn pump components, and actively monitoring the pump motor's health to prevent malfunction and overloads. In the case of high flow rate problems, pump oversizing and incorrect pump speed were identified as potential risk factors that could lead to excessive flow rates beyond the system's requirements. The hazard study advised correctly sizing the pump according to the desired flow rate and pressure demands of the system. Furthermore, it recommends calibrating and controlling the pump speed within the desired range to maintain a stable and appropriate flow rate. The hazard analysis also focused on low flow rate situations, recognizing issues like pump wear, valve misalignment, and power failures as factors contributing to reduced pump efficiency, restricted fluid flow, and pump stoppage, respectively. To prevent these issues, the study emphasized regular maintenance of pumps and valves, as well as implementing backup power supply or uninterruptible power systems to prevent complete flow stoppage during power outages. Lastly, no flow scenarios were also examined, and the risks associated with valve closure and pump failure were addressed. The hazard analysis recommended regular inspection and maintenance of valves to prevent blockages and suggested the implementation of redundant pump systems to ensure continuous operation even the event of pump failure, thus preventing the complete cessation of fluid flow.
Now we proceed with the chamber, which is CH1001 as labeled in the IDP diagram. And process parameter we have flow and the pressure. What if no flow? So the cause because control valve fail close, control fails and close the valve, and air pressure fails close the valve. And the consequences because of clogging cross over the line. And the action that we need to take is to select valve to fail open and install water flow meter and low alarm. And what if high flow? Control valve fails to open and incorrect pump speed. So for these consequences, the waste water from the first compartment is spilling over, and the action that we need to take is instruct operators and update the procedures. Next, what if low flow? So for the low flow, controller fills and close valve, and air pressure fills closing the valve. And the consequences if we may clogging the cross over the line. Then the action that we need taken to select valve to fill open, install flow meter and low flow alarm. Next, for the pressure, we have high pressure and low pressure. For low pressure, the pump wear and tear and the faulty pump motor. So these consequences reduce power efficiency and low pressure, and pump output and low pressure. So what do we need to do? perform regular maintenance, and replace worn pump compartment to maintain the pump efficiency, and monitor and maintain pump motor health to prevent motor malfunction and overloads. Next, we have high pressure, which is the cause because of overpressurization and consequences of pipe burst or damage to downstream equipment. And the action that we need to take is to install of pressure relief valve to prevent overpressurization.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farhan Hanzola, and I will present to you the product pump P1002 HAZOP. For the study node, we of course have a product pump P1002, and process parameters there are two, which is flow rate and pressure. Now for the guide word, there is no high-low for the flow and high and low for the pressure. Now for no flow, the causes are control valve fails to close, plugged product pump controller fails and closes valve. The consequences would be grease chamber overflow and loss of product and possible runaway, with number 2 and number 3 being the same as 1. Now the action that we can take is select valve to fail open for number 1, for number 2 install filter with maintenance procedures, and for number 3 place controller on critical instrumentation list. Now for high flow, there are two causes, one being control valve fails to open, and number 2 controller fails and opens valve. Now the consequences for this, number 1, the aeration tank overflow and possible runaway, and number 2 is the same as 1. Now for the actions that we can take, the first is to instruct operators and update procedures, and for number 2, C3A.3. Now for low flow, the causes would be partially plugged product pump, partial source grease failure, control valve fails to respond. Now for the consequences, for number 1, we have failure to reach product quota, with number 2 and number 3 being the same as 1. The actions we can take for number 1, C3A.2 being also number 2, and number 3, C3A.3. Now for the pressure, high pressure is caused by control valve fails to open, and number 2, controller fails and opens valve. Now the consequences to this is 1, overpressurization of pump, and the number 2 being the same as 1. Now the actions we can take is instruct operators and update procedures, and for number 2, C3A.3. Now for low pressure, causes for this are control valve fails to close, and number 2, plugged product pump. Now the consequences for this, number 1, cause pump vibration, and number 2, same as 1. The actions we can take is number 1, select valve to fail open, and number 2, C3A.2. That is all from me. Thank you.